Now, this type of XSS is the most dangerous one. It occurs when the malicious input in an HTTP request is stored at the back end for later use. So here, the attacker doesn't need to perform any clever social engineering techniques because the malicious script is stored at the back end and then embedded into the pages that are viewed by other users. So the users trust the application and the attacker's script is executed in their browser. It's also known as persistent or second order or type 2 XSS. Okay, so open up Kali, log into BWAP, and open XSS stored blog. And again, it's a sample page. So it looks just like a comment page, and you can add and delete your entries. So let's check in here to show all the entries from the other users as well. And here you can see that comments are listed just like this. So you can view someone else's comments also. Let's view the source page. Doesn't look like there's anything suspicious in the source. And the comments are listed in a table. Okay, so now I'm going to do the same thing that we did for reflected XSS. I'll first try to add HTML tags. So paste HTML H1 tag and submit. And it works. And paste an HTML link and then submit. It also works. Okay, so view page source. Now you see the HTML tags I entered are lying in the source. They are not escaped, not sanitized, nothing else. So now open the terminal to see the code. And this is the code file. Now don't confuse this with SQL injection functions. The actual XSS check happens below. This just prevents you from performing SQL injections on the same form. So if the level is low, there's no check and the entry is added to the database. And this part is for viewing the comments. So if show all is checked, it will use this SQL query. Otherwise, it'll use this one. And after querying the database according to the security level, it will show the data on the page. Now, if the level is high, check 3 is called. For medium, check 4 is called. And for low, there is no check. Okay, so the best part of these vulnerable applications is this. You can view the code and understand the hacking process better. So follow me. Go to Firefox. Now paste the popular XSS payload. And yeah, you guessed it right, document.cookie. So the script executes and the cookie value is printed. All right, so this means that we can run JavaScript on the page. So the next thing to do is collect the session IDs. And that's why I'm going to paste this payload again. And remember to open the Web Developer tool and submit it. As you watch the Web Developer tool, the base64 cookie value is sent to the Cookie Stealer app. So, open the Cookie Stealer app, refresh the page, and here's the cookie. Okay, so go to the session. This is our user. And we're able to get the session ID. So now go back to Kali. This time change the level to medium. And then just add the same payload again. Open Web Developer as well. And submit. But now we cannot see the request sends the session ID to our Stealer app. So then we'll just right-click on the page and view source. So now look, the backslashes are added in before the sign in double quotes. And this prevents the JavaScript payload to execute. So remember, in the code, there is an XSS check for function, and that's called for the medium level. And this function calls another PHP built-in function, add slashes. So that's why we see these extra slashes here. Now, in order to bypass this security measure, there are a few ways. So I'm going to show you just one now. And I'll serve the actual payload code on my host as a script file. And it is completely the same as the previous payload, except for the script tags. All right, so after that, I am just going to call that file from Firefox. And so I'm going to paste this payload here. The source attribute has no single or double quotes. I'm not going to add them because DOM will normalize this code and add it for me. Okay, so open Developer Tools and submit. And look at that, it is done. First, the page includes the script file from my host, and then the script executes and sends the cookie value to the Stealer app on my host. So go to the Stealer app and refresh. And the session value is here. That's right, this is our user. Okay, so go back to Kali. Now let me summarize what we did here. We validated that there is a stored XSS vulnerability on the target application. And why is it stored? Because the payloads we provide are stored at the back end in a database. So here's a question. How can we exploit such a vulnerability to collect the session ID for users? The answer is, we don't need to do anything because we already have. So we injected the XSS payload into the page, and now it is stored in the database. So if any user visits this page, our XSS payload will automatically execute within their browser. So I'm going to open Chrome and go to BWAP. And I'm going to log in as BWAP user number 2. And I'm going to visit the stored XSS page. And yeah, let me just zoom in here for you. Check Show All. Then write something here and submit. Now scroll down to see what you display. And here's your comment. Now, have a look, though. Some of them are not displayed. So let's view the page source now. And scroll down. All right, so look at here. All JavaScript payloads that we tried are here in the page. So as soon as this user opens the page, these payloads are executed in his browser. Then open the Stealer app, refresh the page, and a new session opens. So go to check session. And all right, so perfect. We have the user session value. See, so this is really cool, huh? So go back to Firefox. And I want to show you just a small thing here as well. So set the level to low. And I'm going to paste this payload and submit. Now, look here. This is also a way of exploiting the users. So click this link, and it will display a multi-platform login screen. So this is just, a matter of social engineering, little psychology. So I use this simple login screen, but you can detect and copy other applications of your customers as well. And then serve the HTML interface of these apps to be able to use in social engineering attacks, perhaps, against any of those companies' employees.